Nitin sir, shall we start the session?
Yeah, sure, sure.
Thank you, sir.
Okay, so just give me 1 minute. Okay. So let's get it started. So today we will be having open sessions. So we'll be taking questions and answers from questions. So if you have any questions in the content of week 1, 2, or 3, please raise your hand, and I'll be taking one by one. Okay, so you can please raise your hand, and I will call your name, and then you can ask your questions. Okay, so if you have any doubts in week 1, 2, so please raise your hands. Hello, am I audible?
Yes, sir, you are audible.
Okay, thank you. Okay. Yeah, so yeah, Vignesh, you please unmute and ask your question.
Sir,
Sir, you have said about OHLG, that is observe, hypothesize, learn, and generalize. So,
Correct.
so I'm having a slight doubt that is there only one type through which we will be able to learn about the data, or is there any other type of OHLG like this or any other type?
No, no. So look, this is the pattern that we generally follow in any kind of theory or algorithm that we generate, right? That we design. So that's how the science works. Even in the data science domain, first things what we do, we observe the things, like and based on observation, we make some hypothesis. Like it could we claim something. Those are called hypotheses, and we try to prove that hypothesis using some data, some pre-existing theories, right? And we try to generalize this over the populations. So that is called generalization. So this is the pattern, or you say these are the sequence of steps that we follow to come up with some theory or some algorithms, right? So algorithms may be different, but these are some steps that we follow in any science or any data science domain, right? So first we observe the things around us that happens, right? And then we make the hypothesis regarding that observations. It could be anything. It's not just like mathematical theory or a scientific theory. This could be anything. So these are some steps that we follow. Okay. So there's nothing like predefined steps that we have to follow to come up with some theory or all. But you can think of some basics steps to come up with some algorithms or theories.
Yes, sir. That is in data science. Do we have any other pattern except OHLG to determine data?
Yes, there are, but probably whenever those theories or algorithms were designed, they probably must have started with observing something and then started creating the theorems and creating and exploring the things, right? So they must have proved in the same way.
Yes, sir.
Okay, so they are different algorithms and they work in the different domain, different context, and they are completely different as well. It's not like they have the same kind of domain they are working on. So it depends upon the context that you are working upon or the data that you have. So AI, if I talk about the AI or the data science, there are different branches and they deal with the different aspects of this AI. Right, machine learning that we are going to learn, this is one of that, right? So it deals with some kind of data set and try to find out the patterns or the distribution of the data set, or try to predict based on it learns from the data, right? So this is comes under one of those branch. There are different branches as well, like which deals with the unstructured data and different algorithm which is not falls under machine learning, right? So all those algorithms and all those patterns finding algorithms are kind of do the same, be designed in the same way using these 4 steps, which is observing, hypothesize something, and then prove that hypothesis, right? And then generalizing things over the entire populations.
Yes, sir. And another last doubt that I am having is, apart from you know high-end technological like education, sports, and many other things, how simple can AI get? How simple can it affect our lives in the near coming future? Let's say in the next upcoming 5 to 10 years,
How it can affect the life?
our life in the most simplest way.
No, so look, whatever we use AI or data science in our daily life in many ways. So you must be using smartphones, right? And there you must have seen a different apps or let's take about the YouTube itself, right? So YouTube gives you recommendations. Right? This is one of the example of AI. Right? It has a different locking system, unlocking systems, right? Face detection is one of them, right? So what is face detection? How the mobile knows that the face is come and now I can unlock the screen, right? So this was possible of the AI, and there are many. This is just one of those examples. We are using it in many different ways, even in the sport, right? So you must have seen if you are following some of the sports, right? So they kind of predict something, and they have different technologies when they play sports and all. So all those technologies like are possible because of this data science, right? So they are different domains they are working upon, and that was possible because of the data science. How does it affect? It's a bigger question. I mean, let's should not go to that direction.
Yes, sir. Thank you, sir.
Yes. Okay. So next is Harini. Could you please speak, unmute and uh, ask your
Yes,
question?
sir. Sir, can you hear me?
Yeah, I can hear you.
Sir, can we operate the orange tool in the absence of laptop in our mobile phone?
Mobile phone, you cannot access the Orange. It's designed only for the operating systems like Windows or Linux or Mac. So you cannot work upon the Android or that other mobile operating systems. Right? So it is only for the laptops. You cannot work
Okay.
on mobiles.
Okay, sir. Thank you.
Yeah, Yogita. Yogita, can
Sir,
you please?
good
Yes,
evening, sir. Am I audible?
yes, you are audible.
Sir, what is dot product? Sir, it's my first doubt.
Yeah, dot product. So you do you know about the vectors?
Sir, I have a confusion in that too.
Sorry.
Sir, I have a confusion in that also.
Okay, so have you taken any course where you have learned about the vectors? Maths probably you must have learned about the vectors, right?
Yes, sir.
Okay, so vector in one sense you can think as a quantity which has directions and magnitude both, right? But here in data science we treat every data point as a vector in a higher dimension space. Okay, so let's say so everything is in a space. So on just think about a two-dimensional space where you have age and let's say height. Okay, let me share my screen. Are you able to see black board, black screen? Right.
Yes, sir.
Okay. So okay, fine. So think as a two-dimensional space where you have age and height. So every point will be denoted as a vector, right? So let's say you have a two-dimensional space. So you can see something written on the board, right? Or not?
Yes, sir.
Okay. So here in that two-dimensional space, let's say you have age here and height here. Okay. So every data point. So let's say someone has age of 20 years and height of 170 centimeters. So this is one of the point in the two-dimensional space, right? So this is denoted by vector. where this is the length of that vector and this is the direction. So every data point there is your vector. So let's say this is one of the data point, this is one of the data point, this is one of the data point. So it may denote of the, let's say, age of 60 and height of 172 centimeter. Okay, so these are two data points in the higher dimension space. Okay, so whenever we talk about the data, every data points is treated as a vector. Okay, and why we do that? That will be very clear when we will deal with the higher dimension data and will design some algorithm about that. Right now, understand using this simple data set where you have only two dimensions and every feature is treated as one dimension. Okay, age is one dimension, height is one dimension. Okay, so every data point in that space is denoted as a vector. Okay, now you have two vectors. Now I need to talk about the dot product of that. So the simple formula of dot product is, so let's say you have two data points. I'll talk about in two dimensions, then we can generalize this over higher dimension as well. Let's say A has the point A1, comma A2, and B has the points B1, comma B2. So these are the vectors. Okay, so this is the magnitude in the first dimension, this is the magnitude in the second dimension. Okay, treat this as a vector, treat this as a vector. Okay, now what will be the dot product of these two? So dot product of these two is defined as A1 dot B1 plus A2 dot B2, right? So this is the element wise multiplication plus additions of all such elements. Okay, so first element A1 B1, do the multiplication, plus A2 B2, do the multiplication, and plus this thing. This is called the dot product of this thing. Okay.
Yes, sir. Sir, I had another doubt.
Hmm? So
Sir,
one more
we
thing,
use
if you go into higher dimension, let's say the dimension is n, so your data point will be denoted as A1, A2 up to AN, and B is denoted as B1, B2 up to Bn. Then what will be the dot product of A and B? What will be the dot product of A and B in this case?
A1 dot B1
A.
plus A2 dot
A1 dot, yes, correct. And then up to AN plus BN. And what does this dot product denote? So dot product you can think as how similar these 2 points are. Okay. So if I talk about the mathematical definition of A dot B, if actually uh, 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 the magnitude of A into magnitude of B into cos of theta. Theta is the angle between A and B. Okay. Now, so if I talk about here, if I see in this diagram, so this theta is your angle between these two, and it says that if they are closer to each other, theta will be less, right? So in one sense, A dot B actually gives you the how similar these two vectors are. And when theta is less, cos value will increase or decrease. It will be close to 1 or close to 0.
increase.
When theta is less or close to 0, then cos theta
Mm,
close to 1 or 0. When
It'll
theta is
be
close
one,
to 0, cos
1.
theta is close to 1, right?
one.
You must have seen this here, right? And if I call the two vectors are similar, it means I want the theta to be lesser, right?
Yes, sir.
These two vectors are kind of closer. It means that the theta is less. In this case, my cos theta will be close to
90
1, right?
degrees. Degree.
Close to 1, right? Or theta will be close to 0, right? Am I right?
Yes,
So,
sir.
whenever, and now look at this formula, this particular formula, right? So whenever A dot B takes higher value, it means that those vectors are similar to each other. Okay, and if they take very close to 0, it means that they are not uh, uh, closer treatment. And what we mean by closer of the two data points, that we will talk about when we represent every data points in a by a vector, and what does the similarities between 2 points mean. That will be more clear when we will deal with the text data in particular. Okay.
Yes, sir. Thank you, sir.
Okay. Okay. Any other doubt?
Sir, I had another one. Can we use only bag of words and sentence similarity for conversion of unstructured data to structured data, sir, for computer?
Yeah, there are different ways of doing that. If I talk about the text data set, so think as a two different documents. Okay. Now I'm to convert them into numbers, right? And also the structured data set. So bag of birds is one of them. There are different ways. I'll tell you, bag of birds is not very effective. You will see, we have already designed very effective techniques to convert the text into the numbers, right? So now just focus on the bag of birds, how bag of birds works. Apart from bag of birds, there are different ways to convert those into the numbers. Okay. So there are different techniques. We'll talk about that when we will talk about the text data set in particular.
Okay, sir. Thank you, sir.
Okay. Yeah. So next is
Sir, can I ask one doubt?
yes. Please go on.
Sir, there are two types of data, that is structural and unstructured. So
Mhm.
the data that we store in computers and then pen drives, are
Hmm.
those structured or unstructured, sir?
Okay, so if I talk about those files, right, folders, you are talking about different folders, right, in your local systems or in your pen drive. Those
Yes,
are
sir. Hard
unstructured,
drive or pen
unstructured.
drive.
Yes, hard drive, whatever. Those are unstructured way of collecting your data or storing your data.
Okay, sir.
Okay. Yeah. So next is Kishore Kumar. Could you please unmute yourself and ask your doubt?
Good evening, sir.
Please continue.
Actually, we have a tool like Orange for dealing with structured data. Do we have
Mhm.
tool similarly for unstructured data? Instead of using bag of words method,
Hmm.
is there any other software especially for unstructured data?
Okay. So first, let me clear that Begobus is not a tool. Okay, Begobus is just a way of converting text into numbers.
Yes, sir.
Okay, think as so. Let's say you have to summarize your book, or let's say you have a paper or a document of some 10 to 15 papers, 15 pages. Okay, now you have to summarize this. Right? So if you give it
Yes,
to a
sir.
model like ChatGPT and all other models, or think like a computer, a model, you give that document to that, and that document summarizes it, right? So how the computer is reading those texts? Okay, for that, once we will study about those models, how they work. The first thing comes is how to convert those text into numbers. Okay, so we have to come up
Yes,
with
sir.
some ways. We have to come up with some ways to convert those text into numbers. And Begobus is a way to convert text into numbers. It's not a tool, right? Or like Orange and all. Orange is a
Okay,
tool
sir.
where we deal with the different kind of data set. It's again deals with different databases as well. So I want to go to that directions like databases and all. So there are different tools. If I talk about how to deal with the unstructured data and structured data in a different way, and there are different tools as such. Okay, so databases, to storing databases, there are different interfaces or different platforms that we have, like SQL or no SQL or JSON and everything. These are some ways to store the different kind of unstructured data, and there are interfaces where we deal or we handle such unstructured data set, right? So here you need to know the about the databases and other tools. Okay, so it's not good idea to cover all those things, right? Because it's a very higher things. It won't. And this time we cannot cover all those things now. Okay, but
Okay,
there
sir.
are tools which deals with the unstructured data set.
Okay, sir. Got it.
Is it a Atar, can you please unmute?
Yes, good evening, sir. Very good evening.
Yes, good evening.
Sir, actually, I would like to ask about what can be termed as noise.
Okay, so noise you can think as the error that we have encountered while collecting the data. This is one meaning of a noise. Okay, or error in a simple term that you can call. Like let's think you are measuring the height of all the students in your class. Okay, now since you are measuring height using some of the tool, that tool might not give the precise height, right? Because every continuous variable, whenever you are using some scale, there might be some mismatch in the scale, right? A continuous variable cannot be measured at 100% precision, right? Think as like you are using some measuring tape to measure the height. That tape, while measuring, you might make some mistakes. Okay, so this is one of the reasons for the errors or for the noise in your data set. Right? That error will be very less, so we can handle such error. We don't worry about such error. But like now think of a data set which is stored, let's say height, which is incorrect due to some reason. Not sure what, but this is incorrect in your data set, which is not following the pattern. That particular thing is called noise. Okay, so that noise could be because of different reason. Maybe because of how you are collecting the data. Maybe the error in the tools that you have uh, used for the collecting the data, or maybe the software error, some technical error had encountered while storing the data, right? So such there might be any reason that you have there is mismatch in the data that you have collected. Okay, that is called noise.
So,
Okay,
sir,
and
is it,
in real world data set, there is always some noise, and because of that noise, you see different patterns in your data set, right?
so, sir, for example, in one lecture, Professor Arun said that sometimes considering the noises is also important, which we'll explore in the further lectures.
Correct, correct. That is very important thing. We cannot avoid noise in real world data sets, right? And while modeling those relationships between different features, we have to make sure we have to keep in mind that noise is there, and we have to model noise as well. And by model, just think as a function that is kind of finding the relationship between two different or say different inputs or input outputs, right? So that you can call a model. Okay, whenever we are finding a functions to get the uh, relationship between input output, we have to keep in mind that there is error as well, and we have to make some assumptions regarding error. Okay, so how many of you have listened of linear regression? Have you listened of the linear regression model?
Yes, sir.
What is linear regression? Do you know?
Yes, sir. Linear equation is like we have degree as one.
Okay, so let's forget about linear regression. Do you know what is supervised learning and unsupervised learning?
Uh, so, could you please repeat it?
Supervised learning and unsupervised learning.
No, sir.
Okay, so here, so next thing that we start in the machine learning about the learning is we divide into two parts. One is supervised and another is unsupervised. Supervised, you can think like we are making predictions using the features, different features or different inputs, right? So one of the examples you can think is now we are trying to predict the house rent based on some other features like locality, number of rooms, and all. Right. So we have used some features to predict the price. right? So such tasks comes under supervision, supervised learning. Unsupervised is like grouping, you can think, clustering. Let's say you have a data set, you have to cluster them into different groups based on their feature, based on their similarities. Like, so let's say I'm to divide this whole, there's a bucket of fruits and I'm to divide into three buckets based on their similarities. Like, so I will keep same kind of fruits in one bucket, other kind of fruits in a second bucket, and other kind of fruit in third bucket. Right. So based on some features, I've grouped them. That is called unsupervised learning. Right. With no supervision, we are just grouping them. Okay, we'll talk about this in great detail in coming weeks. Okay, so there also we keep in mind that error is there in the collecting the features. Every feature has some error, some noise. Okay, and while designing those algorithms, once we'll design those algorithms, you will see that we keep noise as well in your data set, right? We cannot avoid the noise at all, right? And one of the different ways, okay, or one of or different ways of coming up the different algorithm is like finding what is the error it's in the data set, right? So that you will see when you will start about the supervised learning. Okay. So noise is always there in your data set, in real world data set, and you have to keep that while designing any algorithm.
So,
Okay,
sir,
so
is it
don't be.
necessarily to be like any error only? It can be also some type of exceptions also.
Yes, that is also called, so like that is also maybe some error, right? That is also in noise. Exceptions are also noise, or exceptions could be outliers as well. Okay. So now try to understand the difference between error, or the difference between noise and the outlier. Outlier, we have to avoid the outliers, right? Error is always there. Okay, noise in the data set is very is always there, but we have to remove the outliers from the data set when we are using any algorithms. Okay, so if that exceptions is causing your outliers, then you have to remove those outliers. And if this exception is not an outlier, then it's okay. We can consider that as a noise. Okay,
Sir,
so
outliers are.
can you see my screen? Is it still visible? Whiteboard or blackboard?
Yes, sir.
Okay, so let's talk about one data set in the two dimension itself. Let's say you have two dimension only, and some data set is like this. Okay, so this is your data points. Okay, and let's say this is your data points. And this all is your data point. Now there is some exceptions comes, and because of that exception, your this comes out to be your data point. So this is your outlier, right? Pattern is like there are in your data set, there's particular pattern that we can see. Some of those data points are in this cluster and some of those are in those groups, right? So this is the pattern I see. But I see due to some exceptions, there that data points come and that is not following the pattern, right? That is called outlier. Okay. So while designing algorithm, let's say I'm designing an algorithm so that we can cluster the groups in these two groups and cluster the data points into these two groups. I have to make sure that those algorithm is not affected by the outlier. So outlier is one thing which is away from your data point, which is not following the distribution of the data point. Okay, which is not following the pattern in the data points. Okay, and noise is something like, so let's say this let's talk about this particular data point. Let's talk about this particular data point. Okay, the true value may be something different, but because of the some error in the measurement that comes out to be here, I can bear with this error, right? This is called noise. Okay. So noise is different from outlier. Don't be confused between these two. Outlier is something which is not from the data set, from distribution of the data set, which is not following the rules or not following the patterns of the data set. That is called outlier. And we have to avoid outlier at any cost. If we are not doing that, then probably your algorithm is affected by the outliers and you may not, your generalization is not good.
So
Okay. But
we can say that outlier is a type of noise, but we are not considering it. We are considering which is following our whatever
no,
we.
outlier generally we don't call it as a noise because it's not a following data set distribution itself, right? So it's not something that coming from the data. It's something out of the data which is not following the pattern, right? So We generally don't call outlier as noise. Outlier is different thing, and noise is a different thing.
So, sir, can outlier be also something like exceptions and errors as well?
Yeah, it could be, but if it is away from the distribution, we call it outlier, and we have to avoid this. We have to remove those and remove that.
Okay, so we basically do not care whether it's error or an exception, but we care whether it is noise or outlier, correct?
Right, correct, correct.
Okay, sir. And sir, one more thing I would like to ask is, sir, what are features? Like, sir, termed about feature engineering, unstructured data and all. So, sir,
Okay, okay. So let's talk about data. We have discussed from the very first session as well. So data here we'll only talk about the structured data. Okay, a structured data set we can think as a data which is stored in the or collected in the table format. Okay, so each input is called one feature. Let's say you have a housing data that we were talking about from the last few days, right? And in the housing data, you have collected these many inputs or these many variables. So one is a number of rooms, right? Number of rooms in locality and distance from a school, the price, right? So all and so these are stored in the columns in the table, right? So these are the columns, and each row, let's say the very first row denotes the one particular house. So one particular house has a number of rooms. The locality is like locality you can think as distance from railway stations, let's say. So let's call it let's call 5 kilometers or distance from a school. And so also locality you can think as a 1 kilometers. Price is 45,000 per month, something like that, right? So this is your one example. This is called one data point in your data, and all these variables are called features. Okay. Let's say if I take one more examples, let's say iris data set. Have you listened of this data set, iris data set? Do you know what is iris data set? Has anyone listened of this?
oh, sir.
So iris is a one kind of flower. Okay, and this is data set. This data set is about the sepal length and petal length of the iris flower. Okay, so iris flower is categorized into three different flowers. So iris has, you can think iris has three kind of flowers, and they have some name, right? Setosa, versicolor, and one more I don't remember the name. So you can think as three flowers, and they have features like sepal length.
Sir, the other one is Virginica.
Vazinika, yeah, correct, correct. Yeah, sepal length, sepal width, petal length, and petal width, right? So they have collected these values or these variables about those flowers. 150 flowers are there, 50 from each class. Classes are that three different kind of iris flowers, and so so what will become features in this case? Can you tell me what are the features in this case? After
So
that you have
length
asked
and
question,
width.
eh?
So
Yeah,
length and
length,
width, whatever.
sepal width, petal width. These becomes your features, right?
Hmm.
Each variables become features. Let's take one more example. Let's take car data set. Okay. Now I have collected different variables for car. So let's say I have collected brand name, which brand it is, which company it is, right? And what is the model, and what is the average that car gives, right? Or what is the price of the car, something like that. I have collected all these variables. So all these called features. Okay. Now if I call, let's say I collected the data for some 2,000 cars, right? So each one is called one data point. So in the tabular format, each column is your feature. Each column is your feature. So what each column will denote the features values for all those data points, right? And each row becomes your one data point, and each row become one data point. Right? Is it clear or not?
Yes, sir. So, for example, Professor Arun said that we are taking it as the input. Whatever the feature are we taking, they are as
Correct.
inputs. So,
Correct. They are input like so the main problems in the supervised learning when you will learn about that. So here what we do, we are trying to find based on some of the features. So just talk about the car data set itself. So let's say now I'm defining a problem, okay, and now you will tell me how I can approach this problem. Let's say I'm collected some feature, but one is the model name, or the company name, and so let's say these are your second-hand cars. Okay, second-hand cars. All are second-hand cars. Company name. Now, how many kilometers it has been run, right? How many kilometers it has run, and what is the current average that it gives, right? Some of the features are collected, and now based on these features, I want to know the price of that current price of that second-hand car. Okay, this is my problem. What is my problem? Using some features, I want to I will give you these features to you. Based on these features, I want to know the price of that car, right? So what I am trying to do here, I'm trying to find a function which take the features, all those features, and gives me the price. You
yes.
see the problem here? I'm trying to find out the functions which takes these features and gives me the price, right? So for this function, what are the input
So, the features we are taking.
features, right? So it's a F here in this case is called model in the machine learning terminologies. That it's nothing but it is a function itself, right? That we have studied in the math courses. So this function takes the different inputs like number of the model name. Let's call this X. Okay, now denote them by X. This is your X1. This is your X1. This is your X2. This is your X3. This is your X4. And since this is your output, that is desirable output, you call it by. Okay, this is X4. This is call it by. Right. So here in this case, what is by? So in this case, actually, I am trying to find a function which takes X1, X2, X3, and X4 and gives me by, right? I don't know this function. And my task is to come up with this function. And there we design different algorithms for finding this function. And you will see that how we design all those algorithms, right? So comes under supervised learning. And now you see these features become your input to the function. Once I give the input to the function, gives me the output. Okay, this is your whole output. Is it clear?
Yes, sir.
Okay.
Sir, I would like to ask that when we have taken the problem of spams in the lectures, right? So, sir said that whatever the emails were there or the spams were there, we won't
Mhm.
consider them as functions there. So, whatever the input was there as
Mhm.
spams, so sir said that we won't consider them as function.
I didn't get your point. What we don't consider as a spam?
Not spam, sir. For example, we took some spams, right? We have to
Hmm.
identify whether the next upcoming message or email is going to be a spam or not.
Okay.
So, sir, in the lecture, professor said that whatever we have as input, like we have the spams as input, we
Hmm.
won't consider them as features.
I have to see the actual point where sir talks about this. I haven't looked at that point. But I can give you the what is spam non-spam problem. Okay, so probably that might solve your issue. I don't know what professor says about that. I need to check that. So let's talk about spam and not spam. Okay, not spam. Mails. This is your problem. Okay. Now you have to tell once a mail come or a message come, you have to tell whether
Yes,
this
sir.
message is
Voice is clear.
sorry.
Voice is not clear.
My voice is not clear. Is it for everyone?
Yes, yes, yes.
No,
Is
it's
it
fine,
okay?
sir.
Yeah, I think it's problem from your side. I think it's okay. So here in this STEM, not STEM classification, your task is you will be given a message and you have to tell whether the message is spam or not spam, right? Again, here message is your text data set, all the text, right? So in this case, your texts are your features. Okay. Now from the text, we have to design features. Okay, so one way of designing features I can think of different unique words in the uh, different unique words in the all the unique words. Okay, all the unique words in the message, and all this become my features. Okay. Now you will see an structured data set, right? All the text. It's not a very easy to understand how to come up with the different features, but you will see how we'll design different features. Okay. Now you think that all the words has been converted into numbers, right? So let's say your vocabulary has 10,000 words, and that 10,000 words are denoted by some numbers, and we have converted into vectors. So these vectors actually becomes your feature. Now based on these features, I am to tell whether my message is spam or not spam. Okay, so these are nothing but we have converted the text into some features. Okay, using some of the techniques, and now we have to pair that. And here comes again the definition of the function. Okay, we have to come up with the function. This take the message or this take the features and tells whether it is spam or not spam. Okay, easy way is to like as I said, the features you can get the different unique words. So I given the example in the very first session as well. Let's say you have two messages. One is message one here, one message two here. Now here you can think as the message reads as wow, you have won lottery, something like that, and something like that. And second message says that dear sir, I hope we are doing good, right? So based on the keywords or based on the unique words, can you tell me which one is spam or not?
So the term lottery indicates something that it is spam.
Yeah, right. So keywords is telling you about the whether it's spam or not spam, right? You can think now we have to learn this function in a way that it takes the keywords or it takes the unique words and tells whether a function, whether a message is spam or not spam. Again, it's a problem of machine learning. Okay, so again we have to come up with a function which take these texts as the input or these features as the input and tells whether a message is spam or not spam. Okay.
Okay, sir. So, sir, in this example only, the example you gave, a similar
Hmm.
type of example was there. So, sir said, as the message is there, so sir said that this is not a feature, that the message as a whole is not a feature that, wow, you have won lottery.
Correct, correct. Okay, okay. So this particular text is not a features. We have to design your features. Okay, and one way I told you, right? So one way is to what are the keywords, right? So whether or say whether lottery is present in the message or not. This is your one feature. Whether some keywords are present or not, these are becomes your feature. This message itself is not a features. We have to convert the text into features because functions doesn't know the text. We have to convert them into features, meaningful features. Okay.
Okay, sir. So this is what feature engineering is.
Feature engineering is a broad topic. It's complete broad topic. You have features. You have to come up with features in a way that it may be useful for defining your predictions, right? So you have to do some mathematics to design your new features. That is called feature engineering, right? So it's a very big topic. Once you will learn about how to come up with the features, you will learn about how to come up with the features.
So, sir, after we are with the features, so how, sir, we design up with the functions in such a way it detects yes or no, whether.
Okay, that is a part of machine learning where we'll learn about the different algorithms, right? We haven't talked about how to find this f, right? We only know that there is we only are saying that there is a one function which takes the input and gives me the output, right? now our task is to find f. And how to find f? There are different algorithms of f, and all those comes in the machine learning that we are going to start. Okay, in future courses. Okay, for now, just think as there is a function which takes the input. So it's like motivation. What we are going to do next? We are coming up with the functions or models which takes features and which take the features as input and gives me the output. Right. This is what we are going to see next in next courses or
So,
next
sir, the
weeks.
model is going to be like it will take whatever is needed as the features, then it will process it as the input, and using that function, it will give the output. It's
Output.
the
Yes. Now
process.
our task is to find this function. We have to design some algorithm. You have to think some algorithm that takes the input and gives me the output.
Okay.
Okay, how to decide this end? There are different algorithms. One I've talked about linear regression is one of them, right? Do you know any algorithm that you have listened of any before that, apart from linear regression?
No, sir.
Decision tree, have you listened of decision tree? Okay, don't worry about all these things. We will design different algorithms that deals with of different kind of data that deals differently, and they works in to find such functions. Okay, so all these functions will come in this course itself. Not all, but some of those functions, but those are easy. Easy function we will talk about. Easy algorithm we will talk about. There are different. There are hundreds of algorithms in machine learning that we study. Okay, some of them will cover in this course.
Okay, sir, got it. So one more thing I would like to ask. Sorry if it is taking much of your time. So I would like to ask you, sir, जो two categories थी on the basis of what we decided, where we are going to use AI and ML. So the
Which
core thing
category?
was
Which category we are talking about?
where AI and ML is used. So, sir, for we are like we have to mimic the brain, human brain into
Hmm.
computers, right? So
Correct. Hmm.
in that category, there was something like text and speech. So, sir, in the speech, uh, Professor Arun said that we can have like writing jokes, detect sarcasm. So, sir, how
Hmm.
this is different from the text?
Okay, so speech is completely different from text. Okay, so let's say speech is much more difficult to process because so text is has some just a simple example by text is easy to understand than speech. So speech has a format as audio files or video files, right? Audio files you can think of as a MP4 files, right? Let's say I'll give you some recordings, and you have to decide who is speaking there, what he is speaking. For you, it's easy to understand because you must have listened that person before, or you know that language, right? But model doesn't know. Now I give you the text, right? Written text. Okay, so text has only few characters. Like if I talk about English letters, it has only few characters, A to Z. Okay, for machines, there are only few characters. But when I talk about different audio files, they are the base characters. There are phonemes that we call, right? Different sounds you can think as. Okay, now model has to process sound there, but in the case of text data set, they have to process only the characters, A to Z characters, right? So here I'm talking about only one language, English. I'm not going beyond that. Okay, different language has different sounds, different characters. Okay, so text data becomes easy in case when we process for the models because they have limited characters, base characters. But in the case of sound data set, there might be lots of noise as well while recording it, and there might be different phonemes as well, base characters as well. And for model, it becomes hard because the one problem with the speech part is that the way it is recorded, right? Their format. It is in the wave form. It's not a written form somewhere, right? Text are something which are written, which are recorded on pages or something like that, right? But speech are in the wave form. They are not written somewhere, right? So this processing wave form is much more much more difficult for model to process rather than text, which is written. Okay.
Okay, sir.
So speech is very difficult to process. Human being, if it is known person, some known person is speaking to you, some known language is speaking to you, then human brain can process that because it has experience to, let's say, some unknown person speaks in unknown language to you. Now it will become difficult for you as well because your brain doesn't know about that language. Brain doesn't haven't listened about that sound before, that person's sound voice before, right? So brain also will become blank in that case, right? Same happens in the case of model as well. It doesn't know any voice because it's a completely different form. Wave form are completely different. Wavelength you can think as, right? So speech is difficult, but we have a ways to process speech as well. Okay, so I will request everyone to don't jump too much because we are taking very first step in the directions of data science. It's not like how GPT works and how a speech we process the speech. It's very higher courses things, right? You are just taking a higher jump. So just take one step at a time. You will see how all those things works.
Definitely, sir. Thank you, sir, for your time and answers and such a clarity. Thank you.
Okay, thanks. So next, Mohammed Fayaz.
Yes, sir. Can you hear me?
Yes, I can hear you.
So this is a bit of a generic question, but humans can often learn new paradigms from just a few examples. But on
Hmm.
the other hand, machines usually need a vast amount of data to do the same thing. May I know the
Hmm.
reason why?
Okay, so one thing, how can you say that human learns only few examples? So the very first thing, neural networks, artificial neural network is taken from the biological system, neural system. Have you learned about neural system in your biology class?
Yes, sir.
Neural system. So what are the basic unit of neural system? What is the basic unit of neural system? Neurons, right? Neurons. Have you listened to neurons? Has anyone listened of neurons in biology
Yes,
class?
sir. Yes.
Yes,
Yeah.
sir.
Yes,
Sir,
sir.
yes.
Right. So they process
Yes.
your whatever they experience from the surroundings, right? They have a different parts. Neurons have different parts like synapses, dendrites, or some. I don't know the biological terms, but so neurons are the basic unit to process those things, right? Those are they become those makes your mind. Okay, so in your human mind there are billions of such neurons. It's not just hundred or thousand neurons. There are billions of such neurons, or they are connected to each other. All the neurons are connected to each other, and there are billions of such connections. Okay, it's a very complicated structure. But in the model that we design, here we try to mimic that structure in some sense. Okay, so we design here artificial neurons, and that network we call as an artificial neural network because it is the idea is taken from that biological neuron itself, right? That's why it is called artificial neural network systems. Okay, and here designing a network which has millions of connections or millions of neurons is not possible at all. Okay, in artificial it is not possible. That is the one reason, right? We cannot mimic a human mind 100% because human mind is a very complicated structure. We cannot completely mimic it, but we are trying to doing to some extent. Okay, this is the main reason behind why model is very slow than human mind, because human mind learns from experiences, their whatever they see from their surroundings and all. And it's not like they see only few examples. Yeah, for some of the cases, it takes only few examples. Let's say talking about a language, learning a language, a newborn baby takes some months or some years to learn a language, right? To get the complete grasp of that language, right? So it's coming from it takes what they are learning, what learning you're talking about, right? So it's not like few examples will make human mind to learn that things, right? So like computations I talk about, human are very slow at computations. If I give you some two different let's say I give you 248 into 310, it will take some time to compute that, right? So here because there's computation power slow for the human mind, but machines do it better. Machines are doing in computations and memorizing and all this. Human minds are doing good because they have a vast network. Okay, human mind is a connections of billions of neurons. Okay, that we cannot practice practically. That is not possible. That is the reason why machines takes lots of data to. We need lots of data to feed into the model to give better performances.
Got it, sir. Thank you. Have a good day.
Yeah, same here. Next is Varsini. Varsini, please. Yes.
So what is the meaning of picture features?
Bits, what? Meaning of
Picture features.
pixels.
Picture features.
Pixels, you mean PIXEL, right?
So no, picture features.
Picture features. I don't know what is picture feature.
So,
Can you write in the chat box?
so PICTUREFEATURES.
Okay, picture features. Where do you listen of that?
So in week 2 classes, recorded videos.
Picture features. Probably they are talking about the images, right? Different pictures. Is it?
Oh, so yes.
So pictures you can think as a combinations of different colors. Every pictures you can think as a different combinations of colors, right?
Awesome.
Okay, that combinations make we have to represent it by numbers. Let's say you have the one pictures and these are combinations of red, green, and blue. RGB pictures you must have seen it. So what proportions of red, what proportions of blue, what proportions of green you have mixed to make that pictures at a different location. Okay, and we input them by numbers, and that way we design features for the image or pictures.
Okay, sir.
Okay, okay, that's those are called pixels actually.
Awesome.
Okay,
Okay, sir. Thank you, sir.
next is Yamuna.
Sir,
Yes, please go ahead.
how AI is able to identify handwritten digits actually?
Okay, so this is again so it's again the machine learning task where we show some images to the model and model recognize the digits, right? So okay, again you are jumping too much, but I give you the idea what happens there. So
But
here let's say
handwriting differs, no, sir. From each person, handwriting differs. Like there
correct,
will
but they have some
be
patterns, right?
different shades
Yeah.
and
So have you listened of MNIST data set? MNIST data set.
yes, sir.
What is this data set about?
Images,
Yeah,
images, collection of
images of
images.
what? Images of what?
So the digits.
Digits, right? Handwritten digits. So this data set is about handwritten digits. Okay, so here let's say one picture is one picture is two, one picture is three, right? So we convert them into numbers first. So let's say so every image, not just handwritten digits or something. Every image you can think as a box. Okay, 3-dimension box or 2-dimension box, and every place we you can think as a grid, and for every place we play this particular box you can think as a combinations of colors. This is again a combination of colors, right? And we encode that combination of colors with numbers and we make a matrix of numbers, right? So this now denote this particular images. We have inputted into the numbers and we feed into the model, and model will tell me about that image, about what is there in the image. So if I talk about this handwritten recognition problem, so you have numbers like let's say one, two. Let's talk about only two numbers. One, let's say one is written there, and two is written there. Okay. Now if I convert into numbers, so it will create a grid. Okay. So now you think here it is all black, here it is all black, here comes somewhere in this box, it comes white. But for this, okay, now if I represent black with 0 and white, so let's say black with 0 and white with 1. Okay, so here it will become 0, 0, 0, and somewhere it will become 1, somewhere it will become 1. Right, in this case, here it is 0, 0, and we'll come up with two different metrics. Right, here, this matrix and this matrix will different. And now models take such different matrices and knows the pattern where zeros are coming, where ones are coming. Based on that, it recognize the digits. Okay, see pattern, right? So though two will be something like this, two will be something like this. Handwritten may be different, but it sees some pattern, and based on that pattern, it recognize the images as well. Again, this is a part of future courses. You are again going very high. It's not needed now, but you can understand that whenever we feed images, we feed them into numbers, and number are converted using pixels. And pixels you can think as a combinations of different colors.
Okay,
Okay.
sir. Okay, sir. Thank you.
Next is Catherine. Catherine, can you hear us? Okay, next is Varad.
Hello, sir.
Yes.
Am I audible?
Yes, you are audible.
Sir, how much data we will need to generate a model like ChatGPT?
For models like ChatGPT takes millions of GBs of data. So Wikipedia, do you know?
Oh, no, sir.
Wikipedia, no?
Yeah. Yes, sir.
Yeah. So how many documents are there in the Wikipedia?
Sir, millions and billions of data.
Millions of billions. This is one particular part of that whole data set. There are different such data sets which were used to train models like ChatGPT. Okay. So it is a millions of GBs of TBs of data set are used for training such models.
Yes, sir.
Okay.
So one more doubt is there. How we can apply AI and ML in our real life problems?
Different problems are there, right? So like predicting something, like let's say I give you a task to predict what whether tomorrow will rain or not. So this is again a task of machine learning. Okay. Next, I give you predict the price of your neighboring house or houses in the different places. This is again a part of your machine learning. Okay. And I give you a design application which gives you the answer of the question that you have put, right? So let's say Alexa. Alexa is one of the example of machine learning. When you talk to that, it gives you the results, right? Chatbot, you must have listened of. So all these are the example of machine learning or AI. Okay.
Yes, sir. Thank you.
Yeah, Arshad.
Yeah, sir. Good evening. Can you hear me?
Good evening. Yes, I can hear you.
Sir, imagine if we had to restart data science with zero data set, what would be
Huh?
our first step?
With the zero data set.
Yeah.
Meaning what?
I mean, if
There is
we
no
don't have any
predefined.
data set,
Huh?
yeah.
So you are
So
saying
what
you
would
don't have
be?
any data set? Okay, so first I'll tell you if there is no data set, there is no machine learning, there is no data science. Okay,
Oh,
it's all data. If we have to design algorithm, we need data. If there is no data, we cannot do anything. Okay, everything is being learned by the data itself.
yeah.
Okay, without data, there is no machine learning. There is no data science.
No, for suppose if we have data, like what would be our first step?
What will be the first step? Now, it's a different problem, right? So, what you want to do with this data? That is the first question. What you want to do with that data? And what is
Okay.
the data set about?
And then next question is like, how do we select the most important features of data set?
Okay. So if I let's say I give you three features and you have to predict the weight of a person. Okay. Now I give you three features. One is name of the person, another is the gender of the person, and another is height of the person. Okay. And you have to predict the weight of the person. Now I ask you only use one feature. Which of these three features will you use?
Yeah, wait.
Weight you have to predict using three features. One is name of the person, height of the person,
Okay.
gender of the person. And I'm asking you to predict the weight of the person.
Okay, height.
Which feature will you use?
Height, so
Right. Why not name?
it's irrelevant to weight.
It's irrelevant, right? How did you decide? Because name and weight is independent to each other. They are not related, right?
Okay.
Right. So in machine learning tasks like prediction tasks, we take those features which are related to output. Output means with whatever you are predicting, right? In this case, weight. We are trying to select only those features which are related to the output. Okay, which are relevant to your model. If I take just name and predict the output, doesn't make any sense, right?
But
So we decide mathematically as well how to find the relevant features, how to find whether they are related or not.
for suppose if we have a large group of data set, then
Huh?
what?
Then again, you have to see. So in the real world scenario, how it works. So you have, let's say, thousand of features, and you are taking some prediction tasks, and it happens in real life. It's not like it's just ideal cases. We have to select some of the features which are relevant. Okay. So have you listened of correlation?
Yeah,
What is correlation?
means like relating the output with the
Relating to
data we
different
have.
variables, right? Relating
Yeah.
to different variables by some number, let's say. Correlation coefficient gives that number, right? Better, higher the number, better the correlation, right? Let's say you have a hundred of features in one output, and I check correlation coefficient of all the features with the output. And now my task is to select only 10 features. This is again a part of feature engineering only, where we are selecting feature selections part, right? Where we are selecting 10 features. I don't want to make use of 100 features. How I will choose 10 features? Mathematically, what I will do, I will find the correlation of every features with the output, and I will select only 10 highest correlated feature, right? This is the one way. There are other ways as well to select the features. Okay. So there's
Okay, it changes.
whole top.
Okay.
Yeah, please go on.
Yeah, like it changes person to person on their
No,
interest.
no, it's not just
Right.
about person to person. It's about when we will design algorithm, we'll see how to select the features as well. Okay, feature
Okay.
selection is again like if I take the name, you will be confused because you must not have listened those algorithms like PCA is one, SVD is one. Feature selection has different algorithms, right? Where we select the different features, right? So it's again a big topic where how to select the features, right? Based on different algorithms. Okay, so it's all will come.
Okay, sure. Okay.
I'm
Thank
just
you so
giving you the
much.
rough ideas what happens, okay, not in the details.
Okay, sir. Thank you so much.
Next is Mohammed Akib. Mohammed Akib. Can you listen us? Okay, probably we can come to you later. Rosita Reddy.
Sir? Yes, sir. Good evening, sir.
Yes, good evening.
So my question was that how do industries decide that whether to adopt AI, ML solutions or stick to the traditional statistical methods?
Okay, so all these machine learning techniques actually are a statistical method itself. Okay, but it falls under a certain domain. We name it as a machine learning. Linear regression, decision trees, not decision trees, but net-based theorems. All these are the statistical tools itself. Okay, so you can think of machine learning, deep learning is a part of statistical tool only, right? There are many in market which are statistical tools, so you cannot say that they are two different things. Machine learning algorithms are statistical methods itself.
Okay, sir.
Okay, we use statistics there only.
Okay, sir. Thank you so much.
Okay. Yeah, Mohammed, I think you were Mohammed left. Is it? Fine. Next is Parthiv.
Good evening, sir.
Yes, good evening.
So my question is that how does machine learning happen? How can we achieve machine learning?
So first tell me what is machine learning?
Uh, the machine learns using the data we give it and then decides what to do.
Okay, so I give you one thing. I'll just tell you one thing. Think machine as a model. Machines means a model or a functions. Learning is uh, finding that parameter. Okay, if functions has parameters, right? So if you can see my screen, as I told you, let's say I'm to predict by as a function of input x1, x2, x3, x4, right? So here I'm to find this function. This function is takes input this, so it could be something like ax1 plus bx2 plus cx3 plus dx4. I don't know a, b, c, d. If I know a, b, c, d, I just give the input. I will get the output. So I am to find this a, b, c, d. How to find this is called learning. Okay, F is called machine or model. So machine learning is about finding the function, or learning is this finding these parameters. Okay, so machine learning is all about coming up with the functions which takes the data as an input and find some insights or insight in the clustering in the data set, or finding some functions to make the predictions and all. So this is called machine learning. Okay.
Yes, sir. Thank you, sir.
Okay.
Sir,
So
one more thing I would
one
like
thing,
to ask.
yeah, I'll come to you again. So one thing I noticed about your question is you are jumping too much for now, right? You have learned about week one, week two. You started with the data. You try to understand what is data set about. But now you are asking me how we pass images to the model, how text works, how text is converted into numbers. This all will come in the future courses. Okay, so don't. It's okay to come. You are thinking that those questions as well. Those doubts are coming to you, but those questions will be answered later, right? It's not you could just jump to the text and start working on the text data sets. Okay, so it's okay to think about those problems, but stick to the basic steps. Okay, foundations is very important. If you make your foundations strong, everything will become easy in the future courses, future learning. Okay, so don't jump. Okay, it's good to ponder about things, thinking about other things which these are questions are coming to your mind. It's all good, but uh, your answers, those questions will be answered later. It won't not be answered now, right? So it's okay if you can stick to weekly content that we have covered. Uh, that let's make those concepts clear first, and then we probably can jump to the those questions as well. Yes, Partip, yes, please go on.
In the first week, we learned about the OHLG technique.
Correct.
So, is there other techniques which we use to analyze the data sets and
No,
functionality?
OHLG is not a technique or not a algorithm. Those are the steps we generally follow in a science. Like we observe something. It's a practical scenario as well, right? You let's say you observe something. Now, based on that observation, you start claiming something that it's happening or something like that. And once you claim something, you try to prove that. And for proving that you select samples, you generate some theories and all. So these are not algorithm. You can think as a steps that we follow to make some or prove something or make some assumptions or make some theories and all, right? So it's not like it's one of those algorithms. It's just a sequence of steps that we follow to come up with some algorithms.
Thank you, sir. Thank you for your valuable time.
Yes.
Excuse me,
Next
sir.
is yes.
Sir, shall I leave the meeting?
Yeah, please. If you feel free to leave the meeting. If your doubts are clear, you can leave your meetings. Anyone
Okay,
who
sir.
wants to leave the meeting, please feel free to leave the meeting.
Thank you, sir.
Sir,
Yes.
sir, I have one doubt. Sir, like, you have converted that message into text, like spam messages and text you converted into numbers. Like, how can we convert text as like messages into numbers?
Again, so I'll tell you what happens. Uh, there are different ways to convert text into the numbers. One way is to you just count number of times, or one way is to whether so think as a dictionary. You have a dictionary, English dictionary. Okay. Now each word take as a feature, and the value will be what whether this word is present or not. Whether this word is present or not. Okay. There are millions of words in the dictionary, right? So there will be millions of features, and features will be whether this word is present or not, right? So this become your features. That thing you can think as how many times that particular word has or how many times that word has come into their document. This is again a feature, right? So there are different ways to come up with the features in the text data set. Okay.
Sir, I didn't understood. Like, I can't.
Okay, so I just give you one example. Let's say in your dictionary, you think dictionary as your vocabulary. Okay, now
Yeah.
my document is very short one. You can see in the screen. So my doc is simple, where I have one sentence only, which is like I study in this school. Let's say I study in a 12th standard. Let's say this is your document. Now I want
Yeah.
to convert this into features. Okay, how I will do? I'm creating features now. Okay, so my vocabulary thing, your vocab you think as a your dictionary. Okay, dictionary has word B1 to let's say BT. T maybe let's say there are 1,000 words. Okay,
Okay, sir.
so very first feature is whether B1 is present or not. Second feature is whether B2 is present or not. And thousand feature is whether BT is present or not. Let's say B1 is A, B2 is AN, BT is your zebra, something like that in your dictionary. Okay, now A is present or not? Not if it is not present in particular sentence, it's become zero. It is zero. Let's say somewhere here it is standard. So that particular feature will become one, here it will become zero, and this particular will become your numbers, a particular sentence, right? This is how you present your sentence. Let's say your come something a zebra was caught, something like that, right?
Hmm.
Now, in this case, if you have to represent as a number, so same way I will use here. It will become one. Here it will become zero. It will become zero here. Somewhere here it will be caught. It will become one here. It will be zero. It will be one here. So this vector will represent this sentence. This vector will represent this sentence. Right. So this is one of the way of converting into text into numbers. Okay.
Okay, sir. Understood.
Okay. So this is not the
Thank you,
only
sir.
way. There are many ways. Okay. This is
Okay.
this. I tell you, this is not an effective way to convert into features. You will see a most effective ways to convert into numbers.
Okay, sir. Thank you, sir.
Yeah. Okay. So I see some of the students also has some doubts. So probably we can take your doubts in the next session. For now, let's close the meeting. Uh, okay. So
Yes, sir.
thanks
We
everyone.
can have the students join next session and take questions.
Yeah, yes, please. Okay. So thanks everyone for joining. We'll take care of your doubts in the next session.
Thank you, student reps, for joining. So you can join. We have live sessions planned for next week as well. Okay, you can join and ask your questions. Thank you all. You may leave. Yeah.